Does the following series converge absolutely, converge conditionally, or diverge? Okay, so we've got negative 5 to the n over n factorial here. Okay, so unfortunately, there isn't one of these that's best to check out. Okay? You might be able to show that this series on its own converges, which would eliminate divergence, but you'd still have to sort out between these two. Or you might try and show that the whole thing absolutely converges, and that might work, but then again, it might fail, in which case you still have to sort out divergence and conditional convergence. Okay. Now, I just typically sort of default to checking absolute convergence, but you might have a different approach. Okay? But I'm going to check for absolute convergence first. So let's consider the absolute value version of our series. So the minus 5 to the n is just going to change to a 5 to the n, and factorials are positive, so we don't need to worry about that. Okay, so does this converge? Well, with the factorials there, I might try a ratio test. And we can rearrange it a little bit. Now this n plus 1 factorial, I'm going to write it as n plus 1 times n factorial. Okay. And similarly, I could write the 5 to the n plus 1 as 5 to the n times 5. And this just makes things cancel out a little nicer. And so our rho value is the limit as n tends to infinity of 5 over n plus 1. Well, this is just going to be 0. So our rho value is 0. This is less than 1. So this converges. And our original series with the negative 5 to the n over n factorial absolutely converges, or we could say converges absolutely.